Hello again. We're now ready to start writing code, which of course means writing some tests to drive that code first. Now, a quick glance at the Wikipedia page for ISBN numbers tells us that there's quite a bit here that we want to consider. If you read through this page, you'll discover that ISBN numbers can be either 10 digits long or 13 digits long, and there is a different calculation for 10 digits and 13 digits. So there's going to be quite a lot to do here. We need to start somewhere. It doesn't really matter where, as we're going to keep building and building until we have all the functionality covered. So let's start with a 10-digit example. Now, if you look at Amazon's website for any book, you can find out its ISBN number. For example, I've got The Odyssey by Homer on screen here, and if I scroll down this page to this section here, we'll find out the ISBN number for this book. Actually, we'll see both the 10-digit and the 13-digit ISBN number. Right now, I'm just interested in this 10-digit one, which you can see on screen right here. So we know that this is an example of a valid ISBN number. So I'd like to start by writing a test to say, if we are trying to validate this number, then we expect our ISBN validator code should return that this is a valid number. We're going to make that our first test. Actually, let's just pause for a moment and talk about why this is going to be our first test. When we write tests, we're thinking about the expected outcomes, not the logic, behavior, the code, the way we might implement it, the architecture, the design. Well, that list just goes on and on. Tests generally will work on the basis of, I expect this particular example to result in the following outcomes. By using lots of tests with lots of examples, that's how we'll know we've covered all the logic that we need. So a good place to start is with an example where we want the outcome to be, this is a valid ISBN. It doesn't matter which example we use for this first test, because we're going to add more examples later. But for now, saying here's an ISBN which we know is valid, well, that's a good example to start with. So let's test that if we use the ISBN we just discovered from Amazon, our code will say it's valid. I'm labouring the point here maybe, but it's an important aspect to understand. When you're writing tests, think about examples and outcomes, not code or how it should work in detail. So we're going to write our new test method, which we'll call check a valid ISBN. I'll use the method stub that we've got sitting here. And before we do anything, the first thing we're going to do is to put in a line of code that says this test needs to fail. And we do that by calling the fail method of JUnit that we saw earlier. And we can call that method without passing in any parameters, like so. And let's just run that to make sure we get a red bar. Well, we did, so that's good. So why did I do that? Well, it's an important first part of test-driven development. Always start with a failing test. Remember, the workflow is red, green, refactor, and now we've got the red part. In a moment or two, I'll show you why this is important. I actually can't do that until we have at least one passing test, so I'm going to come back to this point in a couple of minutes. So we expect then that if we call a method in our ISBN validator class, passing in the valid ISBN we got from Amazon, then it should return that that is a valid ISBN. So let's start writing some code to do that, and we'll need an instance of our ISBN validator class. So let's call that validator, I think. So it's an instance of validate ISBN. And we'll call it validator, and we'll set that equal to a new validate ISBN. Now we're going to call a method in this validator class, and actually we don't yet know what this method is called because we haven't written it. We can call it anything. I think we'll go for check ISBN. So I'm expecting that we should be able to call validator.checkISBN, passing in the valid ISBN number. which we can copy and paste from Amazon, I think. Let's do that. So it's this number here. And if you're just typing that in, that is 014-044-9116. And we'll put the semicolon on the end of that line. Well, actually, I expect this check ISBN method to return something. I think it would make sense if it returned a Boolean. So let's store the result of calling that check ISBN method. And we'll call it result. Set that equal. And for now, just note that I'm passing in that ISBN number as an integer. I don't know if that's right, but, and this is another important part of working out how to write your tests, actually, I don't care if it's right or not right now. All I care about is that if I pass this value into the method, I get a true returned. We might refactor it later to make this another object type, but for now, it seems like an integer will do fine. It's tempting to say, hold on a moment, I know that I really want this to be a string. You could make it a string right now, but if you do that, you're not really following test-driven development. Right now, we only have one example, and the example we have doesn't require this to be anything other than an integer. Because our tests need to drive every aspect of the code that we write, until we have a test that determines a string is the right data type to use, we're going to stick to something simpler. Part of the idea of test-driven development is that the decisions around things like data types, class structures, and in fact the whole architecture of your code in general will change over time as you come up with tests that determine what the requirements really are. Right now, we have just one requirement to ensure that our code says that this one ISBN number that looks like an integer is valid. Okay, so to complete this test, we just need one more line of code which will make the test actually pass or fail. Well, what do we expect to happen? We expect the value of result to be true. So we're going to use a JUnit method. We've seen one of those so far, which was the fail method. We're going to use a method that says we expect this value to be true, and that method is called assert_true. And we pass into that method the value that we want to check. So this final line here says, if the value of result is true, then this test will pass. If the value of result is not true, then this test will fail. Now to get this to compile, we'll need to create the method checkISBN in our validator class. So let's get Eclipse to do that for us. We'll hover over checkISBN and choose this option here to create the method for us. Okay, I'm going to leave that as it is. It's currently got a return false, which is fine for now. And this code isn't quite compiling. That's simply because it doesn't like this value as an integer, I think because of the leading 0. So let's just remove that leading 0. And yes, that code's now going to compile. So let's run it and see what happens. Okay, well the test ran, it didn't crash, and we can see that we got this assertion error. So that means that the last line of our test didn't work. Or in other words, the value of result as it was returned from our checkISBN method was not the value true. So that's our step 1 complete. We've built a test, our test fails, we've achieved the red part of our red-green refactor cycle. Now let's go on to the second step then, which is to write the code that makes this test pass. Now this is going to feel quite counterintuitive if you're new to test-driven development, but the idea here is that we're going to write the minimum possible code that we can to make this test pass. We're not interested in building the correct and full functionality at this point, rather the minimum functionality to make this particular test pass. So how could we do that? Well, we could change our method to always return true. Here's our validate ISBN class, and in the checkISBN method, we could just will always return true. And actually, while I'm here, I'm just going to remove this comment. Now I know that this is not the correct implementation of the check ISBN method. It's obviously not right, but this will make our tests pass, so it's the right thing to do. Don't worry that this feels wrong. We are going to be changing it to something better very soon. But this is another important aspect of test-driven development. At each step, we need to write the code that is needed to get our test to pass, nothing else, even if we know that longer term, that's not the right code. Okay, so let's just prove the point. We'll run this test again. And we've now got our green bar. So that second part of our red-green refactor cycle completed. And step 3 is to refactor. Well, there isn't much we can tidy up here, but I think that we should maybe rename this variable from I to ISBN. I think that would be sensible to do. And I don't think there's anything we need to change in our test. That looks fine for me, so we'll just save that. And as we've changed something, we can rerun our test to check we've not broken anything. I don't expect we have, but no, that's good. We've still got a green bar. Okay, so now we have one test and it's passing. That's a single cycle of test-driven development complete, but to get this functionality working properly, we'll have to write a few more tests, and our code will then be able to evolve as we go forward. Don't worry if this seems like a slow and unwieldy process, it will speed up as we go further. So let's put in a second test, and this time I think we'll test an ISBN number that isn't valid. Now, because of the way that ISBN numbers work, I know that if you change a single digit, you will have an invalid ISBN number. So we can write a method to check this. I'm going to copy and paste the existing method to start. And we'll call the second method check an invalid ISBN. That looks okay. And let's change one of the digits in this ISBN number. I think we'll just change the last digit from a 6 to a 7. And of course, we expect that this is not a valid ISBN number, so we expect the value of result to be false. So instead of calling the assert true method, we'll call JUnit assert false method. So now this test will pass if the value of result is false, and it will fail if the value of result is true. So let's run this and see what happens. Okay, now we've got a green bar, but actually that's not good. The last line of our test is calling assert false, so we expect the value of result to be false if we get a green bar, but we know from our implementation that the value returned from check ISBN is always true. So actually, something has gone seriously wrong. If you remember, I said that we should always start with a failing test. What happened to the red part of our red-green refactor cycle? Actually, I made all this go wrong on purpose to demonstrate the importance of always starting with a failing test, always starting with a red bar. You might have noticed that I had forgotten to put the @test annotation on this second method. So actually right now, this second test isn't running. If we look just above our green bar, we can see there's only 1 out of 1 test that ran. And if I just expand this section here with a little arrow, we can see only the method called check a valid ISBN ran. Now I did this on purpose because it's something that you can very easily do. And of course, if you do make this mistake, if you forget the @test annotation, you might see I've got a green bar, this test is passing, I'm fine to carry on. So we want to always avoid that happening, which is why we always start with a red bar. What I should have done is, before the assert false, put a call into the method fail. So I know this test should always fail. I then run the test. I can see that something's not right. I'm expecting a red bar. I spot, okay, I've missed my annotation. Let's put that in. Now we can run the test. Good, we've got a red bar, so we know that this test is running, and we can see it is this test. Check an invalid ISBN that failed. Now we can try and make this work. We'll remove the fail and see, does it work? No, it doesn't. We expected a false, but we got a true then because assert false didn't work. Now we've got a failing test that we're ready to go and write the code to fix. Well, once again, we want to write the minimum code we need to make this pass. So we could do something like this. Again, I know this is going to be wrong, but it will do for now. What we could do is say, if the ISBN number that's been passed into this method is equal to the ISBN number that we know is true, that was 140449116. If that's the case, then we'll return true. Otherwise, we'll return false. So again, I've said we know this is rubbish code. It's not what we want. There's no sensible logic in here at all. But this code should make the tests pass, so it's the right thing to do for the purposes of test-driven development, if we're not going to try and do any kind of shortcuts. Let's save and run this test again, and now we've got a green bar. So that's good. We've got 2 tests and they're both passing. Now I think it would be nice to start to get into some of the proper functionality of ISBN numbers, so we need to come up with a test that will allow us to start to do that. And I think a good test might be, let's try a second ISBN number to use. This time we'll go to Amazon and we'll find another book. So this time I've got on screen John Steinbeck's Of Mice and Men. And if we scroll down to where we can find the ISBN number, here it is. So here's a second valid ISBN number, and I'm just going to copy that. Now we have a choice. Do we create a new test method for this second ISBN number, or do we add it to this first test method, check a valid ISBN? Well, an important aspect of test-driven development is that each test must check one single identifiable piece of logic, and only one. So normally, you'd only expect to have one assert in a test method, but there are times when you can have more than one assert. But if you have more than one assert, it needs to fit one of the following 2 examples. Either you need to test more than one value to check that something worked correctly. For example, if you expect a particular method to set 3 or 4 variables in a class, you can perfectly validly write tests that assert each of those variables have got the correct value. The second version is when you want to test multiple values that are just different examples of the same thing. And that's what we're doing now. We have 2 different valid ISBN numbers and we expect both of them to return the value true. So we are testing the same principle of logic with both of these numbers. We've just got 2 different examples. So in this instance, it's fine for them to go in the same method. So let's do that. After our first assert, we'll add in a second line, which is we'll set now the variable result to be equal to validator.checkISBN. And we've got our second ISBN number that we copied from Amazon that I'll paste in here, semicolon at the end, and I just need to remove this leading 0 to make this work. And then once again, we can assert that our result is true because it should be true for this second ISBN number as well as the first. So let's save this and run it. And as expected, we got our failing test. We got a red bar, which is good. Had I not got a red bar, I would have put a fail in here because something wouldn't have been right. I always want to see a red bar before I start going forward. And if we look at the failure trace, well, all we can see here is an assertion error. The second line will tell us which line of code the assertion error occurred on. It was on line 15, and I can double click to go to it. But when you have multiple asserts within the same method, I think it's useful to be able to tell us which assert failed. And we can do that by adding in some text to be displayed. And you make that the first parameter of the method call. So rather than calling assert true and then the value of result, we can say assert true, the string, for example, first value, and then the second parameter is our result. Let's do the same down here. We'll say the string this time is second value, and the parameter is result. Now, if I save and rerun this test, we'll see that the assertion error occurred on the second value. Well, that's no surprise. That's exactly what we expected to happen because of the way we've written our code. So we're now ready then to start actually writing some real code to make this test pass. I'm going to start with the Wikipedia page, and we'll click on this link here for the ISBN 10 check digit calculation. I can leave you to read through this if you want to, but what this is saying is that you take each of the digits from the ISBN number in turn, you multiply the first digit by 10, the second by 9, the third by 8, and so on, add up all the numbers that you get, and divide it by 11. If the result is divisible by 11, it's a valid ISBN number. If you're a bit confused or a bit scared by this mathematics, don't worry, I'm going to show you this simplified in just a moment. What I do want to point out is that on this Wikipedia page, there is some code here for how to validate an ISBN number. Now, the last thing we're going to do is copy that code because we don't know if it's right. So don't look at that code. Don't be confused by that. We're going to be doing this the correct way using test-driven development. So we need to start by understanding that calculation. So just to make sure we understand the mathematics that are required, I've got on screen here the valid ISBN number that we got from Amazon. So to check this ISBN number, what we do is we take each of the digits in turn and we multiply the first digit by 10, the second digit by 9, the third digit by 8, and so on, right down to the last digit, which is actually that check digit, which we're multiplying by 1. So 0 times 10 is 0, 1 times 9 is 9, 4 times 8 is 32, and so on. We then get all of these numbers and we add them up, and that gives us a total of 132. We take that 132 and we divide it by 11, and that gives us the number 12, and it's 12 exactly. Because this is an integer, the number that you get, it's an exact integer, there's no decimal point needed. That means this is a valid ISBN number. Let's have a look at an invalid ISBN number. I've taken the same one as above, but this time I've changed the last digit to a 7. Well, we'll multiply each of these digits out. When we add them up, we can see that gives us 133. When you divide 133 by 11, you get 12.0909 and so on. That's not an integer, so this is not a valid ISBN number. So this is the logic that we need to code up. So I'm going to be writing code in this validate ISBN method. And the first thing that I realise is that I must make sure my ISBN numbers have 10 digits. And the example we're using here is a 9-digit ISBN number because it really should have had the 0 in front. So now our test requires us to make a design decision. Should we accept integers, and if the integer is less than 10 digits long, add extra zeros in the front in this method here? Or should we say that our ISBN number should be a string and should be 10 digits long? Well, I think we'll go for the idea of saying it should be a string. Now, right now, I'm not worried about the length of that string. I'm not going to concentrate on is it 10 digits long or not, because if I want to do that, I really need to write a separate test. And actually, we will be writing that test in the next chapter. So for now, let's change our code to make this a string. And just to make this compile, I'm going to change this into a string. And actually, I can put my leading 0 back in now and save that. And I'm going to update the tests at this point to make sure that they pass as well. So once again, we can put this as a string with the leading 0 back in. The same for this one. And the same for this one. Okay, so everything is compiling, which means I can rerun my tests. And I'm going to rerun my tests at this point, because prior to making this change, this single change from an integer to a string, my check an invalid ISBN test was passing. So I think it makes sense to check that that is still passing, that we've not broken anything with that minor change we've just made. So let's rerun our tests. Good, so check an invalid ISBN is still passing, and we can carry on writing the code now to hope that our check a valid ISBN passes, and you might notice that even though it's failing, it's only still failing on the second value, so we've not broken anything by that little change that we've made. So we'll have a go then at writing this code, and because we need to put in some proper logic, I think we'll remove all the code we've got in here and start again. So we'll have a go at writing this code together. I hope you're following along with me. Actually, I'm going to make a mistake in here, which we'll discover a little later. I'm doing this on purpose to make a point about how test-driven development works. But I want to say this now because if you spot the mistake, don't worry. I want to pretend that I don't know I've made it. If you haven't spotted the mistake when we get to it, well, that's probably a good thing because we'll discover it later when we write another test. So the code that we're going to write then is take each of the digits in turn, multiply the first by 10, the second by 9 and so on, add them up and divide the answer by 11. So let's start with a variable to store the total. And then we'll need a loop. And we're going to loop for 10 characters. I'm not going to worry about the fact that our string might be the wrong number of characters. For now, I'm just going to code up assuming it's 10. So we'll loop from I is 0 to less than 10. And within this loop, what we'll do is we'll start with our string, ISBN, and I'm going to call the charat method to get the character at the position I within that string. So that will give me each of the different numbers in turn in my ISBN number. And I want to multiply that number by 10 minus I. So that starts with 10, then 9, then 8, and so on. And I want to add the result of that to our total. Okay, that line looks like it's going to compile. So by the time we get to here outside the loop, we now should have a total value that we want to divide by 11 and find out if that's a whole number or not. So there's a mathematical way of doing that. It's called the modulus operator, which in Java is the percent sign. So that's going to be if total percent 11 is equal to 0, that means it is divisible by 11, then we're going to return true. Otherwise, we'll return false. So I believe that this code should work. I'm going to see if it works in a minute by running the tests. As I said earlier, there is a little mistake in here. If you spot the mistake, well done. If not, that's okay. Don't worry about it. But I want to point out the mistake is there. I don't want you to think I'm writing this code, I've made a mistake, and you start emailing me to tell me. Okay, so let's save this and we'll rerun our tests. Okay, well that looks good. We've got a green bar. And I think that's a good place to end this chapter. So far, we've written 2 different tests. We've used those tests to drive some basic functionality. And we've now written at least the start of the functionality we need to validate ISBN numbers. Now this code is not complete just yet. And in the next chapter, we're going to take it further. But actually, most of the next chapter is going to be a worked exercise, giving you the chance to practice the process of test-driven development before we get into some more complicated features. So I'll see you when you're ready in Chapter 4.